Hello, and welcome to the last lesson for chapter 3. We're going to work on lesson 3.7. Sorry to overwhelm you, but here we're going to learn about rational functions. Rational functions are functions where you have a polynomial in the numerator and a polynomial in the denominator, and we're going to call them P and H. Something that we have to remember about fractions, because rational functions are fractions, is that when you have 1 over a really large number, the larger the number the denominator gets, the smaller the overall value. And then the opposite is 1 over the smaller the number and the denominator gets, the larger the overall value. And you can play around with that in Desmos. But that's gonna relate to something today. So we're gonna learn about what's called vertical asymptotes. You may have heard the word asymptote before. So it's P and Q, Px and Qx are have no common factor. So that's one thing we're gonna establish. And X where Q of X equals 0. That's what our asymptote is gonna be, okay? So let's go to our book here. Let me bring it up for you to see. So to find the vertical asymptote, hold up in my computer, but I didn't. So to find the vertical asymptotes, an asymptote is where a value, the function gets really, really close to it, but then doesn't ever actually arrive there. It can't touch it. It's like it gets really, really close, like kryptonite, but you can't get there. So you can see this function here, 1 over x minus 1. If you're coming from the really large numbers and you're getting small, it looks like you're getting bigger and bigger and bigger and bigger and bigger, and then it just goes to infinity. It never actually arrives at anything. When x equals 1, it's not, you can't evaluate it x equal to a positive 1, because when you put 1 in for the x, you get a 0 in the denominator, so the function is undefined there. So the asymptote is the value at which this function is undefined. And then from the negative direction, as your x value gets bigger towards 1, it gets, all of a sudden it feels like it gets really, really negative, but then it drops off. Okay, so the vertical asymptotes occur at values of x where Q of x is 0. So we're going to set that denominator equal to 0 and find out what values could cause this function to be undefined, and that's where our asymptotes will be. Okay, so let's look at one. So we're going to look at a vertical asymptote for 29. So 29 says, sketch the graph of rational function, indicate any vertical and horizontal asymptotes in all intercepts. So for 29, we're going to sketch a graph. And we're talking about a vertical asymptote. So we're going to learn about horizontal asymptotes in a minute. So the y-intercept, we can put 0 in for x. And if we put 0 in for x, we get a negative 12 over 6, which is a negative 2. So that's one point that we know. Okay, and then that vertical asymptote is where this denominator is equal to 0. So vertical asymptote, x plus 6 equals 0. So at x equals a negative 6. So at x equals a negative 6, 1, 2, 3, 4, 5, 6. We're going to draw a dotted line, and we know that it's going to get close to that, but we don't know if it's going to be going up or going down. We just know that there's going to be a vertical asymptote. Now, we do know that the bigger your denominator gets, the closer this overall value of the fraction gets to 0. So when x gets really, really large, it's getting really, really close to 0. And when x gets smaller, so let's say at a -2 or -3, then it's going to be at a -4. So when x is a -3, this will be an overall value of a -4. So it's going to be somewhere down here. So it's going to be going like this. And then this is going to, it looks like it's going to head up towards 0, but never ever cross there. So we have to look at what, if there is a horizontal asymptote, an asymptote that is getting really close to some y value. So there are 3 possible situations with a horizontal asymptote. And that is all based on the degree in the polynomial in the numerator and the degree of the polynomial in the denominator. So if the numerator degree is smaller than the denominator degree, our horizontal asymptote will always be at just y equals 0. Okay, and you can see that's the case for 29, because there's no degree in the top in the numerator and there's a 1 degree in the bottom. So the top is smaller than the bottom, which means we're headed in this situation that we talked about up here. The denominator is going to get really, really large while the numerator stays the same. So our number is going to get really small, which means we're going to have a horizontal asymptote at y equals 0. Horizontal asymptote at y equals 0. So we have this vertical asymptote, and then we got to look at what's going on over on this side at y equals 0. Okay. And what we can do is at this -6, so we could pick a number, say maybe -12, and see what's going on over here. So a -12, so if we let x equal a -12, then we would get a -12 over a -6, which would be a +2. So somewhere over here, we're going to be at a +2. Okay. So we already know that we can't touch y equals 0. We saw that over on this side. And this is going to go, so whatever this is doing, it looks like it's in what we might call like the 4th quadrant. It's shifted a little bit. Then this one is going to go in a mirror. It's going to go in a reflection in this like 2nd quadrant. So this is going to go really high that way, and then towards 0 this way. And so you need to be able to explain these things. So there is no x-intercept. So there's no x-intercepts because we have the asymptote at y equals 0. So let's go ahead and put this into Desmos and see what it looks like. So we have, oops, I typed it in wrong. It's a -12 over x plus 6. Okay, there we go. That's why it didn't look right. So now you remember, you can't see where the asymptote markings are. We just kind of drew those on the paper, but you can see it gets really, really close to a -6. And if you zoom out, you can kind of see it better too with the horizontal asymptote going here left and right at y equals 0, and then that vertical asymptote at -6. And you can also see that if you were to go to your line over here where you typed your function and put it and convert it into a table, you can put in a negative. We could go up here and hit -6 there, and then we can make the ones up here a -7. So you can make this a -10, make that a -9, -8, -7. So you can see that the numbers are getting extremely large, and then at a -6, it's all of a sudden undefined. And then if you went a negative, and you could even do here, do -6.01, there's a value. See how large it is, but when it gets to -6, it's undefined. And then on the other side of -6, you could say -5.999, and it's the opposite, it's a -1200. And then it goes from there. See, that's pretty cool when you can see the table. Okay, so, oops. Okay, so let's go and look at the next one. I have is -10, number 10, I mean. So, number 10. So number 10 says h of x is equal to a -3x squared plus 12 over x squared minus 9. So we can immediately put our y-intercept. I like that one because it's just when x equals 0. So when x equals 0, this goes to 0, and we have 12, and this goes to 0. So 12 over -9, which is a -4/3. So we can kind of start getting a graph going here. So 0 and a -4/3. Okay. So the x-intercepts we'll worry about as we move along. So let's look at our vertical asymptote. Is always where your denominator equals 0. So x squared minus 9 equals 0. So that means we have to factor this. Is going to be x minus 3, x plus 3. It's that special factor. You could also move the 9 to the other side and take the square root. So you're going to have asymptotes at both 3 and a -3. So you're going to have two vertical asymptotes. So at a -3 and 3. So -3 and 3. Pretty cool. Let's see what's going on in between there. And then we are going to look to see if we have a horizontal asymptote. So let's go back to our rules. So the one that we learned so far is when the numerator degree is less than the denominator degree. So let's look at our function. They're equal. They're both a degree of 2. So that's our second option. So our second option is when the degrees are the same, which means their coefficients. There's a horizontal asymptote when y equals the ratio of their coefficients. So there's a horizontal asymptote at y equals a -3/1. So at a -3. So we're going to go down 3. So this is at a -4/3. So at -3, there is going to be here. So we've got things going on. We've kind of broken into 6 different areas. So then, right, so the x-intercepts are going to be basically where the numerator is equal to 0. Because if you set this equal to 0, when y is 0, and you multiply through by the denominator, that eliminates the denominator. So we just have to look and see where the numerator is 0. So if we -3x squared plus 12 equals 0. So I'm going to factor out a -3, and we have x squared minus 4 equals 0. And so that factors into x minus 2, x plus 2 equals 0. So we have zeros at, so we have x-intercepts are zeros at x equals 2 and x equals a negative 2. So you just need to be able to show me these, how you're working these out. I know that you can double check everything in Desmos, which I'm happy for you to be able to do, but I want to make sure that you know why it is the way it is. So we have an x-intercept at 2, which is just inside here, and one at negative 2, which is just inside here. So it looks like, so it can't touch this. So it looks like these are going to go like this, right? Because the numerator, negative 3x squared plus 12, is a parabola. And then we're going to see what's going on outside there. So let's go to Desmos and put it in and see what it looks like. So we're going to put in y equals, and then I'm going to get my fraction started, and then go up and edit my top. Okay, so I've got a negative 3x squared plus 12 over x squared minus 9. Wow, isn't that pretty? I'm going to zoom out so we can get a bigger picture. I think I typed something. A negative 3x squared. I want the negative to stay there. Okay, that's right. So make sure that the negative stays in the numerator. When I typed it, it automatically just went out in front. So then it changed my x-intercepts. So we have to make sure we've got those x-intercepts at negative 2 and 2. Very cool. So I just got to add in the little pieces in the bottom left and the bottom right in my graph. This right here where my mouse is moving, I have to add that into my paper, and then this one here over here on the bottom right. So I'm going to show you that. I added those pieces in right here and right here. Okay. So let's look at our next problem, number 43. And we're going to do the same that we just did. This is getting fun, isn't it? All these things that you can do and guess at the graph without actually looking at it in Desmos. I think it's so fun. Okay, so I'm going to start with my y-intercept. To me, that's always the easiest. It's when x is 0. So 0 plus 0, so that'll be minus 6 over 0 minus 1. So negative 6 over negative 1 is going to be at 6. So there's my y-intercept. And before I draw my graph totally, I'm also going to look at my x-intercepts. It's where my numerator is 0, x squared plus x minus 6. So it's a trinomial, so I'm going to try to factor it into, they need to multiply to a negative 6, but add to 1. So I'm going to do x plus 3 and x minus 2. And sure enough, I get x equal to a negative 3 and x equal to 2. Okay, so I'm going to, my y-intercept is at 0, 6. And then I've got an x-intercept at negative 3 and 2. Okay, and then we've got our vertical asymptote, where the denominator equals 0. And that's where we get x minus 1, x plus 1 equals 0. So we have vertical asymptotes at negative 1 and 1, which is cool because that's in here. And then right here. Okay. This is going to keep things interesting, right? And then our horizontal asymptote is we have our degrees are both degree of 2. So it's just at the coefficients, right? 1 over 1. So at y equals 1 over 1, which is 1. So we have at y equals 1, we have a horizontal asymptote here. Okay. So it means it's going to get really, really close to that, really, really close to that, really, really close to this, really, really close to that. And then down here, same thing. Let's just check it out in decimals. I'm going to, and I'll save all this and I'll put the link so you can find my decimals, how I typed everything in. So I'm going to put this in parentheses. So x squared plus x minus 6 parentheses divided by x squared, nope, squared minus 1. There it is. Oh, I gotta turn up my other graph. Okay, so there it is, just like what we drew. Isn't it pretty cool? Very cool. Okay, the next one is number 13. So let's go back and look at my paper here. And so number 13, let's see what they're asking us to do on number 13. It says, find the domain in the vertical and horizontal asymptotes. Okay, so this one is y-intercept. It's going to be 0 over 0 plus 1, so it's just going to be at 0, 0. And the x-intercepts, it's just where 3x squared equals 0. So the only place that this can equal 0 is when x is 0. Okay, so that's it, 0, 0. Well, this is pretty uneventful. And then what about a vertical asymptote? Is where the denominator equals 0. So that's at x equal -1. And then we have our horizontal asymptotes. And let's just see where that's happening. Okay, so that's our third situation for the horizontal asymptotes here. We've got the first one when the numerator is smaller than the denominator degree. The middle one is where the degrees are equal to each other. And the last one is when the numerator degree is bigger than the denominator degree. There is no horizontal asymptote. Well, all right. None. Okay. So let's just go ahead. There's our x and y intercept. We have a vertical asymptote at x equal to -1. Let's just see. If we put, let's say we put 10 in here, we're going to get 10 squared is 100 times 3 over 11. So as it out here, it's going to get bigger. So the smaller numbers we put in here. So let's say we put in 1/2, smaller, smaller. I think this is, oh, let's say we put in a -1. It's at undefined. We already knew that because that's where our, so I think it's going to go like this. But let's go ahead and check it out in decimals. We have y equals 3x squared over x plus 1. Let me turn off my purple graph here for a minute. I typed that correctly. 3x squared over x plus 1. Okay, so that actually, we have that vertical asymptote is the only thing we have going on in that one. So let's draw our picture. This did not go how I thought it would. So it came down and touched and then went off in this angle here, and then comes from the angle and goes up to about a -11. That's an interesting one to draw. Okay. We have another kind of an asymptote, and that's called a slant asymptote. And let's just take you to the book where we talk about the slant asymptotes. It's on page, where did they go? Oh, page 290, I think, here. Okay. Let's go back to my paper. We'll look at the book. So it's page 290. At the top here. So it says, if the degree of the numerator of a rational function is 1 greater than the degree of the denominator, the graph of the function will have what is known as a slant asymptote. Using long division, we can write it out like this. Okay, so when we divide it out, we get this linear ax plus b comes out, and then you've got this remainder. So it says where ax and b are the first two terms of the quotient, and s is the remainder. Because the degree of s is less than the degree of q, the value of the function approaches 0. So this goes away. So you really just have this linear asymptote, which will go at a slant because of the slope a. Okay, so let's just look at example 6 in the book, and we're going to do a few. So it says, find the slant asymptote of this function here. So we're going to take 6x squared minus x minus 1 and divide it by 2x plus 1. Now, the book doesn't show you any work for that. So let's do that work so you can see where this comes out to be. Okay. So 6x squared minus x minus 1. We're going to do the synthetic division. So we've got 6 and -1 and -1, and then 2x plus 1 is really a -1/2 when we set it equal to 0 to divide. So we're going to bring the 6 down and multiply it by -1/2. So we get a -3. And then maybe I can't do the, let's see, -4, and then that'll be a +2, and that comes out to be a 1. So I have to do long division. I don't know why I tried to do it this way. 6x squared minus x minus 1, and we're going to long divide it with the 2x plus 1 because we don't know if it's a 0 or not. And it's not an even 0 because there is a remainder. So 2x times what to get me to 6x squared will be a 3x So 3x and 2x make the 6x squared. 3x times 1 gives us the 3x. And when we subtract, that changes that to a subtraction. Those cancel, and we have a minus 4x, bring down the negative 1. And then 2x times what gives me a negative 4x. So a negative 2. So this becomes a negative 4x minus 2. But when we subtract, we get a positive and a positive. So those cancel, and we have a remainder of the positive 1. So that's where we get 3x minus 2 and the remainder of 1 over 2x plus 1. That's where they get this. So the 1 over 2x plus 1, the denominator gets really big. So this remainder piece goes to 0. And we're left with this slant asymptote at 3x minus 2. Okay, so very similar to our one that we just did, right, where we had that weird asymptote here. We just didn't see it. So on number 13, we have an asymptote. So let's go back to that number 13 and see if we can figure out that slant asymptote. So if we take that number 13 and just figure out that, what we were looking at, 3x squared, if we long divide that by x plus 1, we'll have to multiply by a 3x. So this would be 3x squared plus 3x. Subtract, subtract. Those cancel. A negative 3x remainder. So we have to multiply by negative 3. So this will be a negative 3x minus 3 plus and plus, and then those add out. So this is it with a remainder of 3 over x plus 1. And so we have 3x minus 3, which that is actually 3 times x minus 1. Well, it's just this line at 3x minus 3. So if we go into number 13 and draw the line at y equals 3x minus 3, we should have a slant asymptote at that line. Let's just go and look at that just for fun. We're learning something new. Let's go back up here and let's just do y equals 3x minus 3. And you can see, yep, it's right there. Pretty cool, pretty cool. Okay, I'm gonna take that out because, okay. Okay, so let's move on to another one. There we go. Another slant asymptote of number 54. And problem number 54 says h of x is x squared plus 2x plus 1 over x plus 3. And so we can look at that because we're going to have our y-intercept when x is 0, which means those two terms go 0, this goes 0, so it's at 1/3. And then our x-intercepts are going to be, we're going to set x squared plus 2x plus 1 equal to 0. And that's just going to be x plus 1, pretty cool. So x minus x equal a -1, and it's a multiplicity of 2, so it's going to be a touch. So remember, we got to start bringing that up too. Pretty cool. So 0 and 1/3 is our y-intercept. We have x-intercepts at -1, and it's going to be a touch. So it's either going to come down and touch or go up and go back down. Okay, so do we have a horizontal, or let's look it up, the vertical asymptote. And that is where x plus 3 equals 0. So there's an x equal to -3. So we have, this is at -1, so -2, -3. So we have this vertical asymptote, okay. And this is a touch, so we still don't know if it's going to go boom, boom, or boom, boom. I'm guessing it's going to go like this and slant that way. Okay, well, let's just guess. And the horizontal asymptote is going to be a slant because there's no horizontal, but it's a slant because 2 minus 1 is 1. The difference between our degrees is 1. So there's a slant asymptote. So slant, let's figure out what that is. So we're going to take x squared plus 2x plus 1, and we're going to divide it by x plus 3. So it's going to take an x to get to x squared plus 3x. And then we have to subtract everything. So those cancel. We're left with a -x plus 1. So it's going to take a -1 to get there, and -x minus 3, and subtract here. So that actually makes them both positive. So those cancel, and we get a 4 remainder. So this is x minus 1 and 4 over x plus 3. So that goes to 0. So we're left, a slant asymptote is actually at this right here. Y equals x minus 1. Okay, so at the equation 0, y equals x minus 1. So if x is 0, it's going to be at a -1. So it's going to be down here. That's only at 1/3. This is, let's see, at 1, we're going to be at 0. At 1, we're going to be at 0. At 0, we're at -1. At -1, we're at -2. At -2, we're at a -3. So it's, the asymptote is a line, but it's a dotted line because it breaks that. So it's going to go like this, come down, and it'll be a slant at this. And then there's going to be one here. Okay. So let's go put our function in. Let's see, number 54. Parentheses again, because this is a big one. X. Let's see, x squared plus 2x plus 1. Okay. Just little x's. Oh, I didn't name it. When you do a big X, it thinks you want to do a slider bar function. And nope, this is an X, and they should all be little x's. Okay, there we go. So yep, just what we drew. Isn't that so cool? I just think they look so cool. Awesome, awesome. Okay, so 2 last problems here. And they are to do with rational functions with common factors. Okay, so when you have rational functions that have common factors, it's going to create a hole where there's an undefined value. Okay, so let's look at the check it out on number 7 on page 291. So on 291, we're going to look at where there's holes here. So you can see the example from the bottom of page 290. Example 7. It's x minus 1 over x squared minus 3x plus 2. When you factor them, you can see that the x minus 1s cancel, but it reduces to 1 over x minus 2. But you have to remember that that x equal to 1 is still undefined, because it would cause an issue because of the denominator, even though it gets canceled out. So that's why in your graph, you'll have a circle there at that value where it's undefined. So let's look at chat, this check it out here. So it's telling us to sketch this. So we need to factor our denominator here into x minus 6x plus 1. No. X minus 3, x minus 2. This one, the 6's always screw you up, because the 6 and 1 and the 3 and 2 can kind of make the similar combination. So our x minus 3's are going to cancel. So we're going to have an undefined value at x equal to 3. And then we're going to have a y-intercept at a negative 3 over 6. So a negative 1/2. Our x-intercept is going to be at x equal to 3, where that equals 0. Our vertical asymptote, it's not going to, because these cancel, right? We're going to, actually, because these, let's see, because those factors cancel, we're going to have a vertical asymptote at x equal to 2. And then our horizontal, the numerator exponent degree is less than the denominator, so it's going to be at y equals 0. So let's just see here. We have our vertical asymptote at x equal to 2, and then we have our horizontal asymptote, and then we have an x-intercept at 3, and it's multiplicity 1, so it's going to cut through, and then we have a y-intercept at 0 and a negative 1/2. Okay, so let's go see this in Desmos here. Y equals 2x minus 4. Okay. All over x squared. Did the wrong one. I mixed my two problems together. It's x minus 3. So I get for looking one way and looking the other. Okay, so that's x minus 3 over that. So yes, so we've got this whole at x equal to 3. So we can't have an x-intercept there, right? Because of that. So this is a hole right here. So it doesn't show that. So let's just click on the gear here. So it should be at 2, it's undefined. And then let's put in 3, it's undefined at 3. But the cool thing is you could put in 2.5 and it'll have a value, but then at 3 it's undefined again. So that's pretty cool. Okay, let's look at number 63. I'm going to go ahead and put the graph in right here just because we're already here in Desmos X. Whoopsie. 1 equals x squared and okay, let's just go come back and look at that here in a minute. So what I'm going to do is just put in that's actually, did you get it? This is no, that is 63. I didn't type in 60. This is the check it out. Okay. Okay, so actually I'm looking at 63. Sorry about that. Okay, so we're looking at 63. So we have our y-intercept is where I like to start. We're putting zeros in here for x. So we get negative 10 over negative 2, which is 5. So there is our y-intercept at 5. And then our x-intercept is going to be where our numerator is equal to 0. X squared plus 3x minus 10 equal to 0. Does that factor x plus 5x minus 2? Yay, it does. So we have x-intercept at x equal negative 5 and x equal 2. So let's just write that x equal to negative 5, x equal to 2. And they're both multiplicity 1, so they're going to cut through. Okay, and then we have a vertical asymptote at x equal to 2, where the denominator equals 0. So x equal to 2. This is at x equal to 2. So, oh, geez. So that means, yep, these two factors cancel because this factored into x plus 5x minus 2. So at x equal to 2, there's a hole. This is a kind of an asymptote there. Excuse me. So this is going to be a line. This is going to be interesting. Let's go look at this. It's x squared plus 3x minus 10 over x minus 2. But it doesn't show the, so let's look at the gear. Let's make the table so we can see the values. So you don't see it on there, but at x equal to 2, it is undefined. And then at 2.01, there's a value again. And at 1.99, there's a value. It's just completely undefined right at 2. Isn't that cool? Okay, one last one, number 60. Y equals 2x minus 4 divided by x squared minus 4. I'm going to turn off this red one here. So it's going to be looking like this right here. So it looks like we've got an asymptote and an asymptote going both ways. So there's vertical and horizontal. And okay, let's just check it out on paper here. Use it with what we already have. Okay. So we're going to draw a picture here. So we have a y-intercept at 0 and 1 because those are both going to go away. -4 over -4 is 1. We have x-intercepts if there are any. So this factors into 2 over x minus 2, and this factors into x minus 2 and x plus 2. So there's going to be a hole at x equal 2 again, where we think there's an x-intercept, but there's really not. And then because the denominator exponent is bigger than the numerator, we're going to have a horizontal asymptote at y equals 0. So that's there. And then our vertical at x equals 2 and x equals a -2, although x equals 2 can't, we already know is 1 because there's already undefined, and then x equals -2 is already undefined. Okay, so this one just kind of goes away because it's undefined there anyway. And then the vertical asymptotes are here, which the one at 2 really can't be just because it gets canceled anyway with the numerator. And we saw that. And let's go into our last look here. That's at -2. And then if you make the table, you'll see that 2 is undefined. Woo! we learned a lot today about all these asymptotes, vertical and horizontal and slant, and got some practice with our long division. So that wraps up chapter 3. Make sure you go in and check out what you should be reviewing for the test over chapters 2 and 3. And I will see you soon.